Good morning. Can you all hear me? Thank you. Okay, it's 8 o'clock. We'll get started. Just going to, again, go through the syllabus here and make sure everybody's on track with what they're doing here. All right, so we are on now Thursday, January 28th. And today we're doing the calculating of K. And then on Tuesday, it'll be a review. And on next Thursday, there'll be no class. So the test will be due next Thursday, so a week from today. You can do the test anytime up to the due date. All homework and, sorry, not homework, all extra credit will be due on Wednesday, 11:59 p.m. My recommendation, get all the extra credit done early. And somebody needs to mute because I'm hearing myself. All right. Does anybody have any questions about the schedule? Any questions about the schedule? Everybody's fine with this? Now, what should you be doing to study? Can anybody answer that question? What should you be doing to study? There's actually two things.
Test?
I'm sorry?
Practice test?
A practice test, Savannah. Which practice test are you talking about?
Test 1 practice test?
Yes, let's have a look at it. Well, Savannah, can you share with me why you think it would be useful to do the practice test? This ungraded copy of test 1?
The questions might be a little bit different, but it's the same format as test 1 will be.
Actually, let's go a little bit deeper than that. I'd say it's the same test. I really would. Yeah, the numbers will be different, but it's not. It's more than just the formatting. The questions. I mean, it's the same test. I mean, it pulls from the same pools. Everything. It's the same test. So if you theoretically take this test enough times, then you can you'll be taking the whole test. Wow. All right. So I always get well, it always surprises me when people don't take the ungraded copy of test 1 at all, and then they just take test 1 and then they fail it and they wonder why. And well, I don't think there's any real mystery at all behind that. So anyways, that's where we're at. Okay. The other thing, well, the second thing that you can do to help with your studying is to do the extra credit, and you can earn a bit of extra credit at the same time. That's good too. Now, remember, I had a little bit of a suggestion for you with the extra credit, and that was, I'm going to go in here as a student. Sometimes it can be hard to keep track of the extra credit you've done, you haven't done, right? So go into the grades section as a student, and you can see all the extra credit is in here. Now remember, you don't get the full point here, you get half of everything. So 1, 2, 3, 4, 5, 6, 7. So you can earn an extra 3.5 points. This gets added on to your test score. You get whatever you get from here. You don't have to get the full 100% of each one. You get whatever you get, and you'll get your 100. You get your 3.5 points here, and you can add that on. So I think that's useful as well to do. Remember, all that is due the night before the test is due, and you don't have to wait till next week to take the test either. Okay. This is interesting. I've not seen this arrangement before. Two-page view. No, I don't want to do that either. Okay, that's better. All right, so we're on to calculating equilibrium constants. Here we go. So if you look at the kind of question that I've got here, I've got calculate the equilibrium constant K for the following reaction at 1000 degrees using the following information. SO2 and O2 are placed in a flask at the beginning of the reaction, and they both have a concentration of 1.000 molar. After reaction has reached equilibrium, the concentration of SO3 is 0.9250 molar. Show a table and setups for the equation. So what we're looking at here is we're given the initial concentrations of the reactants, and we're assuming here that there is no product initially. Of course, what happens is as it reacts, the concentration of these will go down and the concentration of the product will go up. That's because there is no product at all initially, and eventually it'll reach some sort of equilibrium value. So with that information, and here we're given the concentration of a product, we don't have to be given the concentration of a product at equilibrium. We can be given the concentration of any of these reactants or products at equilibrium. And we can, with that information, calculate what the equilibrium constant actually is. All right, so let's see how that works. All right, so here's how it goes. I've got the reaction there, 2SO2 plus O2 gives 2SO3. The initial concentration of the reactants is 1.000 molar, and the initial concentration of SO3, which is the product, is 0, and that's been written down there. At equilibrium, we can actually get an idea of what the concentrations of the reactants and products are actually going to be based upon the stoichiometry of the reaction. By stoichiometry, I'm talking about the coefficients in front of the reactants and products. So here's what we know. We know that at equilibrium, we're going to have used up twice as much SO2 as O2, and we're going to have gained as much SO3 as we have SO2. This is just based on the coefficients here. This is not coming up quite as well as I would have liked because these are actually in color. Let me see. I think I will download the PowerPoint here because this part's in color and I want to show you the colors. So give it a second to pop up. Yes, Cade, that's right. Okay, so hopefully you can all see that. You can see the different colors. So the reds are SO2s, the blues are O2s. So you can see initially we've got the same number of blues as reds. We've got 6 blues and 6 reds in the SO2 and the O2. There's no SO3 available. Now, if I'm saying what the equilibrium might look like, which might consist of 2 molecules of SO3 having been formed, Where did those 2 molecules of SO3 come from? Well, they came from the addition of 2 reds and a blue, so 2 SO2s and 1 O2. So 2 reds and a blue form 2 greens. So you look at the equilibrium, you see that the blues have gone down by 1 and the reds have gone down by 2. And that's kind of what's happening here. This is where these numbers come from, the minus 2z, the minus z, and the 2z. Let's talk a little bit about the signs here. These are the reactants. We know what's going to happen with the reactants. The reactant concentrations are going to go down. The product concentration is going to go up. Why? Because initially there is no product, and that will be the direction in which the reaction will go, will be towards the products. So the products will increase in concentration, which is why it's positive 2Z, and the reactants will decrease in concentration. And they decrease in concentration in a direct proportion to the coefficients that are out the front. So it's minus 2z for SO2, minus z for O2 because there's just a 1 in front, and plus 2z for SO3. Does anybody have any questions about setting up that table? Okay. So how do we handle this? Well, we've got to figure out what this z value is. Now, we already have a little bit of information from the question, and we were told from the question that the concentration of SO3 at equilibrium was 0.9250 molar. So that means that the 2z here is actually going to equal 0.9250. Then we can calculate z, which is 0.4625. So this magical z here that we're talking about, we can actually calculate. After that, we can go ahead and we can plug in the z value into what we're seeing here in equilibrium concentrations. So remember what K is going to be. It's going to be SO3 squared over SO2 squared times SO2, and all of these are concentrations at equilibrium. So that'll be 2z all squared, 1.000 minus 2z all squared times 1.00 minus z. So that's all we've done there. Does anybody have any questions about how that setup has occurred? Okay, so the next thing we're going to do is we plug in z, and then we can calculate what K is. Now, one thing I haven't talked about here is why we're getting what we're getting as far as the significant figures go. So I'm going to go through that right now. So the 280 value is right, but if you plug it into your calculator, you may get something a little bit different than 280, but this has been adjusted for significant figures. So let's look at the SO3 first. So the constant, this is at equilibrium. So the concentration of SO3 was given, and it was 0.9250 molar. That was in the question. The SO2 is 1.000 minus 2z. 1.000 minus 0.9250, which was 2 times 0.4625. And that comes out to be, I think it comes out to be 0.075. I'm right. Yeah, 0.075. So remember the rules here. This is 3 places past the decimal. And this is 4 places past the decimal. So the answer comes out to be 3 places past the decimal. But you'll also notice that that's only 2 significant figures. Now for the O2, it's 1.000 minus Z, which is 1.000 minus 0.4625. And I'm going to do a little math here because I don't want to do this in my head. And we get 0.538. And again, it's 3 decimal places minus 4 decimal places gives 3 decimal places. So it's these values that get plugged in. And the K value then is going to be SO3 squared, which is 0.9250 squared. And that's over 0.075 squared times 0.538. Now this is where the significant figures come into play. That's only 2 significant figures. So the answer comes out to be 2 significant figures as well. I think if you plug it into your calculator, it comes out to be something like 282 or something like that. And that gets rounded to 2 sig figs, which would be 280. Does anybody have any questions?
Yeah. Dr. Musgrave?
Yeah.
Just one quick question. The formula, will that be on the test, or is that something that we're gonna have to memorize?
You're talking about the reaction.
Uh, Perhaps that, and then the formula for K.
Well, the K, no, the K is always based on what the reaction is. It's always products over reactants. So it's SO3 to the power of 2 divided by SO2 to the power of 2 times O2.
Okay.
No, I mean, it's always based on the reaction you're given, the K expression. It's not something you have to memorize per se, because you have to be able to get it from the reaction. Okay, any questions? Any other questions? Okay, let's take a look. I have in the calculation of equilibrium constant folder a worksheet. Let me download it. And there you go. So this is the worksheet for practicing these equilibrium problems. I'm going to do a couple more of these examples, but I also have after that all the answers, and the answers are complete with a full analysis of the significant figures as well. So it explains exactly how we get these answers along with the significant figures that we get for them too. All right, let's take a look at. I'll do 2 examples here.
Sorry, you said that was on the PowerPoint where it has the breakdowns of it, including the significant figures for that.
No, it's in this document called Equilibrium.
The PDF. Okay.
Yeah, Equilibrium Constant Problems. It's in the calculation of equilibrium constant folder. You'll find it there with the practice quiz and the credit quiz for the extra credit there as well. Okay, I think I'm going to do 3 examples. I'll do 1C, 2C, and then 3C. So you'll notice this reaction is the reverse of the other one we're talking about. So Lonnie, I want you to take real note of how I get the K expression here. It'll help answer your previous question, okay?
Yes, sir.
Okay. So what we do is we write out the reaction. And we'll have the initial molar. We'll have the equilibrium molar. And in the initial molarity here, we're starting out, it says with the SO3 is 2.00, sorry, we're doing C here, so let's hit 1C. We're doing SO3 is 1.00 molar. And the supposition, of course, or the assumption is that the products are going to be 0. Now at equilibrium, it'll be 1.00 minus 2Z, and this will be 2Z and Z. Now it's plus 2Z and plus Z because we know that the reactants are going to go down and the products are going to go up. Does anybody have any questions about the setup of this so far?
I do.
Yeah.
How did you, I see that in the question, it says start with SO3 equals 2M.
No, we're talking about 1C.
Then...
No, we're doing 1C here.
Okay, so it's just, there's 3 parts to the question then. Okay.
Well, no, there's three different questions here. These are all different questions. We're only interested in, we're doing 1C right now.
Mm-hmm.
Is that okay?
Yep.
Okay. Now we're told here that at equilibrium, SO2 is, concentration of SO2 is 0.900 molar. That means that Z, which is the concentration of, oops, wrong one, 2Z. The concentration of 2Z is equal to 0.900. And Z then would equal 0.450. Now, how do I get that with the significant figures? Well, it's all based upon an addition rule here. So we got 0.450 plus 0.450 would give 0.900. The 2 here is a counting number because we have an exact number based on the coefficients here. So it's 0.450, which is the same number of places past the decimal. Anybody have any questions? So if we look at SO3, it's 1.00 minus 2Z, which is 1.00 minus, whoops, yes, that's right, 0.900. And that would be 0.10. Now the reason for that is because that's based on the number of places past the decimal. 2 places, 3 places, so this is 2 places past the decimal. So SO2 is going to be 0.900, we're given that. And the O2 is going to be 0.450 because that's just Z. So the K expression here is going to be products over reactants. It's going to be SO2 squared times O2 over SO3 squared. So we substitute in all those values we calculated. So the SO2 is 0.900, that's squared. The O2 is 0.450. And the SO3 is 0.10. and that's squared. And that, whoops, squared. And that comes out to be 36. And that has two significant figures because 0.10 has two significant figures. Okay, does anybody have any questions about 1C? Lonnie, does that answer your question about how to get the K expression?
Yes, sir. It does.
All right, we're going to look at 2C now. And 2C is 2NO plus Cl2 gives 2NO Cl. The initial molarities. And if we're going to find the equilibrium molarities as well. So the initial molarities, we've got 2, and we've got NO here. NO, we're starting with 8.000. The Cl2, we're starting with 1.500. And the product is going to be 0. And at equilibrium, it'll be 8.000 minus 2Z and 1.500 minus Z. And 2Z will be the product. So again, you'll see the reactants are going down, so they're negative, negative 2Z or negative Z, and the products are going up, so it's positive 2Z. Does anybody have any questions so far? So we're told here that at equilibrium Cl2 is 0.5000 molar. Okay. So that's one we don't have to calculate, at least for the concentration of Cl2, at least the final concentration of it. But we do have to calculate Z, and this is how we're going to do it. So we know that 1.500 minus Z equals 0.5000. So we have to do a little bit of algebra here. All right, I'm going to put up a little poll here for this calculation of Z. So give me a second here to get the poll going. Okay. All right, that'll do it. Okay, so let's see if you can come up with what the correct answer is here with the correct number of significant figures. So the poll should be available to you. Okay, I'll give you another 10 seconds to come up with it. 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, so I'm ending it now. Share results. Okay, so you all should be able to see the poll here. So there's 18 of you who put in responses. 13 of you said it was 1.000, and you're correct. All right, so let's see how that works. I'll do the full algebra here. So it'll be z negative z is equal to 0.5000 minus 1.500. Excuse me. Then z then will equal 1.500 minus 0.5000. So this has 3 places past the decimal. This has 4. So the answer is going to have 3 places past the decimal. So it'll be 1.000. Does anybody have any questions? Yeah, it's a little bit tricky, isn't it? All right. So that's how we're calculating Z. And let's see, we need to get the concentration of NO, which is 8.00 minus 2Z. And that would be 6.000. We've already got the Cl2 concentration as given. And the concentration of NaCl is equal to 2Z, which is going to be 2.000. Then we can go ahead and do our K, which is going to be NaCl squared over NO squared Cl2. And that's going to be, let's see, NaCl, that's a 2.000, that's squared, over, see, NO 6.000, and that's squared as well. And the Cl2 0.5000. And that comes out to be, if you look at the answer here, 0.2222. Oh, sorry, 0.2222. Yes, so it's 4 significant figures there because these all have 4 significant figures in them. Does anybody have any questions? Anybody have any questions at all? Okay. Let's take a look at 3C. This will be the last one we'll do. So this one is 2P plus 5Cl2 gives 2PCl5. And I haven't checked, but I'd like everybody to make sure they got their video on, please. I will check in a minute, though, probably. So the initial molarity doesn't look very pretty, does it? Let's try that again. We'll have the equilibrium. Now the initial, we're looking at 3C here. And our starting for the P is 8.000. The Cl2 is 0.50, sorry, no, Cl2 is 1.500. And the PCl5 is 0. At equilibrium, it'll be 8.000 minus 2z, 1.500 minus 5z, and positive 2z on the PCL5. Okay, I'll stop there for a second. Does anybody have any questions about where I'm getting any of that from for the equilibrium? Everybody's completely hunky-dory with that? Now, at equilibrium, we're told that the concentration of Cl2 is 0.5000 molar. So this allows us then to calculate 1.500 minus 5z is equal to 0.5000. Okay, so now we can calculate z. I'm going to have you work on that for a bit. I'm going to create another poll here. Okay, so let's have a look at that. See. Okay. Okay, let's see if we can come up with this poll here. I'm going to put it up. Okay. All right, so tell me what you think Z is with the correct significant figures. Okay, I'll give you another 10 seconds. 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay. I'm going to end the poll. I'm going to share the results. Interesting. Interesting. So what's the right answer? Yeah, see, a lot of people said it was 0.200, but also a lot of people said it was 0.2000. Well, the answer is, well, you'll see in a second, Kate. The answer is 0.200. So how do we get that? Well, let's do the full math on it and we'll see. So we have, I'm going to shorten this out a little bit. 5z is going to equal 1.500 minus 0.5000. I've taken off the negative here. So 5z is equal to 1.000. Z is actually going to equal 0.200. The reason for that is because the 5 here is a counting number. it's not really 5z. It's actually z plus z plus z plus z plus z plus z, which is an addition problem, effectively, because 5 is a counting number, which means it goes by number of places past the decimal. So 1.000 has 3 places past the decimal. So z, in order to add together to give that, has to be 3 places past the decimal as well. I know it's a little bit tricky, isn't it? Does anybody have any questions? Anybody have any questions about that?
So if it's a counting number, it doesn't matter if it's being divided, you're going to treat it like an addition or subtraction.
Exactly right, Savannah. And, you know, it's anything that's like a coefficient is always going to be a counting number because it's an exact number. All right, so now we can get the other values here. So we've got the P, which is going to be 8.0. I'm going to stop sharing that. Yeah. We got the P, which is going to be 8.000 minus 2z, which is 8.000 minus 0.400, which would be 7.600. The concentration of Cl2 is already given. The concentration of PCl5 is going to be 2Z, which is going to be 0.400. So once we come up with the K expression, K is going to be PCl5 squared over P squared Cl2 to the 5th. And then we can plug everything into that. So I'm going to actually remove some of this. So K equals, let's see, PCl 0.400 squared over the P squared, which is 7.600 squared and that's 0.5000 to the 5th. And that comes out to be, well, it's going to be 3 significant figures, so it comes out to be 0.0886, because that's going to be 3 sig figs. All right, does anybody have any questions? Well, it turns out you guys are lucky because the question I've put on the test really can't take sig figs into account. It's a shortcoming of my courses, unfortunately. What I probably will do for the future, although you guys are not going to be unlucky enough to be facing that, is that I'm probably going to add in some significant figure type questions in with this question in the future. But you guys won't have to worry about that because I'm not going to do it to you right now. All right. Let's see what's going on here. Here we go. So I'm just going to show you an example of the question. But you'll see there we go, calculating K. So that's what the question will look like. I mean, it can vary. I mean, the reaction can vary too, but the coefficients will certainly vary as well. And these numbers will vary. And then you'll come up with the value of K. And this is just very similar to what we've just been doing. All right, does anybody have any questions? Well, why don't you all give that one a go, the one that's right there, and then I'll go through it with you. So, you know, we've done a bunch of examples now. I think you should be able to have a go at this, just based on what we've been doing. Hopefully you've been taking some notes. Or you can go back and you can take a look at the example on the PowerPoint if you haven't been taking notes. But if you haven't been taking notes, well, you know, that's up to you. I can't make people take notes. Never have. So I'll give you a few minutes. And then I'll go ahead and I'll do the example in full. So I'll give you about, and I'll give you about 5 minutes or so. Okay, let's go ahead and I'll put this down. It's not as bad as it looks, I don't think, really. So we'll do A plus 2B gives C. The initial is 1.00 on the A, 2.60 on the B, and the C is 0. Equilibrium, 1.00 minus Z, 2.60 minus 2Z, and Z for C. Now we're told here that the concentration of A at equilibrium, 0.40 molar. So 1.00 minus Z is equal to 0.40. So Z is equal to 0.60. So 2 decimal places. Any questions so far? So A, we've already got as being 0.40 at equilibrium. That's given. The concentration of B is 2.60 minus 2Z. And that would be, let's see, so 2.6 minus 1.2 would be 1.40, right? Any questions so far? And C is equal to Z, which is going to be 0.60. So the K is equal to C over A times B squared. Which is going to be 0.60 over,
I thought A was equal to 0.40. That's what the problem says.
yeah. Well, where have I got that wrong?
Where it says A in brackets when you have it as given.
At equilibrium, yeah. At equilibrium, yeah, I don't see a problem. I don't think I've made a mistake. Have I?
No, it says 0.4 at equilibrium, and in the second bracket it says 0.04 given, so you're good.
Okay. And the B is 1.40 squared. Okay, then you can come up with the result. So what do you all come up with for that? Did anybody come up with anything for it?
I got 0.77.
0.77. Okay. So that would be the answer you'd put in. There's no units on K. I mean, you could put in units if you wanted to. The units would be, in this case, anybody know what the units would be if you decide to put in units? Not that you would here because you haven't been asked for units, but what would the units be? Does anybody know?
Would it be molarity?
No, it wouldn't be molarity.
Or like molar?
Sorry?
Degrees Celsius over.
Let's have a look. See if somebody's put it in chat here. Yeah, 1 over m squared is right. Yeah, so m to the negative 2. I'll show you how you get that if you were interested in the. You see, C is in molar, A is in molar, B is molar squared. So it'd be 1 over m squared, or m to the negative 2. If you wanted to put in units, but we don't usually put units on big K. But that's the thing is that leads to confusion when we talk about little k, which is the rate constant, and then people say, "Oh, I don't need units for that." Well, no, you do. You need units for little k. You don't need units for big K. All right. Does anybody have any questions? Does anybody have any questions?
So is the formula for K given?
No, you have to come up with it, Ali.
Okay.
You have to come up with it based on the reaction. It's always products over reactants. So in this case, it's C, which is the product to the power of 1 over A times B squared. You see, it's always based on what you're given as a reaction.
This might be a stupid question, but where did the squared come from?
Which squared? The B squared?
A times B squared, yeah.
From the 2B. The 2 in front of the B.
Okay. And you're doing that first before you're going to multiply those numbers. So that way it doesn't.
That's right. Yeah. That's
okay.
right.
Okay.
Does anybody have any other questions?
Dr. Musgrave, I got a quick question. So if it was, say for instance, A plus 3B, will we still square B, or would that be
no, it'd be B cubed then.
Okay, gotcha.
You see, what you're doing is let me get out of this here. What you're effectively doing, I think you're all maybe looking into this a little bit too deeply, is, well, let's say I'm gonna do something different here. Let's say it's 2A plus 5B gives 6C. Now let's make it even different from that. We'll do 2A gives 5B plus 6C. Then the K expression, you see, we're multiplying everything together. So it'd be products over reactants, B to the 5th, C to the 6th, over A squared. See? And that's all you do. You're just multiplying all. You see, if you look at what I'm doing here, 2A is like A plus A. That becomes A squared. This is B plus B plus B. Maybe I shouldn't have done 5 anyway. You get the idea. And it is, of course, it's C plus C plus C plus C plus C plus C. Right. So everything here just gets multiplied together. So even it's all added here, it gets multiplied together down here in the K expression. Does anybody have any questions?
Can you tell me again what your final answer was for that with the significant figures?
I think it was 0.77, I believe.
Okay.
I actually didn't figure it out, Katie. Somebody else figured it out and told me what it was. Does anybody have any other questions about any of this calculating K stuff?
Do you know how they got the 0.77? Because I'm getting a different answer.
Right. I didn't figure it out. So let me see. Let's see if I can bring. I can't take it back to where it was, unfortunately. It's been too many things have been added. So I can't go back and do the math on it, unfortunately. Sorry.
I keep getting like 0.51, and I don't know if anybody else got that, but I didn't get 77, and I don't know how they got that one.
It should be 0.60 over 0.40 times 1.40 squared.
Yeah. So let me write that down again. So what's on top? It's 0.40, right?
No, 0.60.
0.0. Okay. 0.60 over, was it 0.40?
0.40.
Yeah, times 1.4 squared, right?
Yeah, 1.40 squared.
Okay. So that's how it should look. Let's go. Let me take a look at the calculation here. I've got. Okay, so what I would do is, if it was me, I know it's a bit tricky, but I do 1.4 and then square it, multiply by 0.4, and then divide by 0.6, and then hit equals, and then take the inverse of it. Where's the inverse? 1 over x. There you go, 0.77. Did you see that, Emmeline?
Okay, yeah, I do.
Yeah. Not sure. You might have squared something you shouldn't have squared, possibly. I don't know.
Or if you put it in your calculator, you just have to put parentheses around.
Yeah, that's right. Yeah, that'll work too. Anybody got any questions? Any other questions about that? Okay, let's have a little chat about the test and the way it's going to run. So what's going to happen is that you'll be allowed to. I always get pushback against this, but you just have to deal with it, unfortunately. You'll be allowed to have a sheet of paper, a blank sheet of paper, scratch paper, to do your work on. Now the catch here is that, yeah, I give you, it looks like 2 hours here. I think I give you some extra time on the real test, because down the bottom, and I don't have it here on this test, there's going to be another question. It's going to be a box, an empty box that you can actually type your work into. So this is where people give me pushback, because they say, well, why can't I just copy in my, or just email you my work or whatever, and why do I have to type it all in? Well, it's because you get to see the results of your test as soon as you submit it. So I don't want people to be able to adjust their work before they send it to me. So the only real solution to the problem is to have you type it in. So if you've got doubts, if you want, I mean, that's the thing. If you get the question right, it's fine. But if you get the question wrong, you're going to want a chance of getting some partial credit on it. And the only way you can do that is if you type it into that box down the bottom. Then what'll happen is that if you want extra credit on something, you email me and say, well, please look at my. So if you want partial credit on something, please look at my work in the box, and I'll go look at it, and then I'll give you partial credit for the question. So you tell me which question you want fixed up, and then I'll look at the work in the box. And that's how it'll go. Like I said, I always get pushback on this. People are always screaming at me saying, well, I don't want to type all this stuff in. Well, I'll give you extra time. I give you extra time to do it. People just don't want to do it. That's really the bottom line.
Since emails are timestamped and our submission is timestamped, there's no way we could. Oh, I guess you couldn't send it before the test is out because it's on
right.
a log.
That's
Okay.
right. It's under an log. So yeah, I get that kind of thing all the time. But do I want to be looking at timestamps and checking on people? No, I don't. So yeah, I see your point, but at the same time, I don't see it as being a great trial because I'm giving you the extra time to do it. And yeah, people could type in whatever they want or whatever they don't want. They don't have to do it for everything. They just do it for the things that they think they might want partial credit for. But if you're sure about your answer, then you don't have to put in anything. The answer will come up that's correct, and you'll be happy as Larry. But and there always seems to be that the people who do well always seem to put in the work. The people who don't do well, they're the ones who are always screaming at me, saying, "Oh, gee, I wish I hadn't had to type all that stuff in." Well, I say too bad. type it in. That's all I'm saying. All right. Does anybody have any other questions about this so far? Okay. Well, just a reminder about this ungraded copy here. So the real test is this test, right? So I mean, you can do this test as many times as you want. You know, you'll get the answers will pop up. You can do the test partially as often as you want to. If you just want to do one question and just continually do that question, that's fine too. I have no problem with that. Let me see. So just a reminder, if you're having trouble with the formatting of the questions and knowing what's being asked for, then the other thing I have is this, the practice test 1 videos. So these are all the questions and how you do them. So, you know, you can look at these to get an idea of how to do a question if you're not certain about what it's asking for. This will tell you and you'll be able to do it. And, you know, I'll say it again. I always say this. I say it till I'm blue in the face. Don't leave it till the last minute. Don't leave it till the day it's due. Get it done early. Get your extra credit done early too. All right. Does anybody have any other questions, general questions about the test here? So Tuesday, I'll be doing review. Okay, so review, it'll be a review for the test. Nobody has any excuses at this point. You can't say, well, I'm not going to start studying until he's covered all the material. Well, I've covered all the material. So you don't have an excuse. You should be starting to study. I know a lot of people are going to leave it till the day it's due in order to do it. But I don't think it's a smart play. Anybody got any questions? All right. Well, okay, we'll leave it there for today then. And I will see you all on Tuesday and we'll be doing test review.
Thanks, Professor.
Have a good day. Thank you.
Thank you.
One quick question.
Yes, Emily.
Regarding just because I tried to do the practice test and I didn't do too bad, but there was still almost an issue with my numbers. For the value of Q, it's kind of straightforward, right? It's whatever. Oh man. Let's see. Because I don't know if I'm getting it wrong or not.
Okay, hang on. I'm going to share again. I'm going to share my screen again. I think I'm unsharing it. Okay. I'm just going to show you an example here. It's actually pretty easy. I think you might be overthinking it. This is just this question here.
Number 12, or yeah, number 12.
Yeah. Well, it's actually, this one's a little bit trivial, but it's this one would be just B times C over A. Do you see it?
Yeah.
But let's say it was 2C, right? It'd be B times C squared over A.
Right, because it's, maybe I did that, maybe that's why I did that wrong. Maybe. So you're saying it's, so it's always going to be like products over reactants, right?
That's right. Mm-hmm.
So if it was,
sorry, Emlyn. I can barely hear you.
So it's regarding that it'd be B times C divided by A?
B times C divided by A in this one.
And that's just, okay.
But what I was saying was if it was 2C, then it'd be B times C squared.
C squared. Okay.
If it was 2A, it'd be B times C squared over A squared.
Okay, so I just got to keep an eye on the numbers that are right up there, because if it's more than one, then you're gonna have to square it or cube it or whatever it's gonna be.
That's right.
Okay. I think that's where I might have missed that part.
Well, it's just like we were doing for K. It's going to be the same thing.
Okay. All right, I'll go ahead and give the practice test another try on those again and see if my results come out better.
Okay, sounds good.
All right, thank you, Professor.
No worries, Emmeline. Talk to you later.